Imagine a world where the frozen silence of the Arctic hides a violent secret, a scar from deep time waiting silently beneath a kilometer of crushing ice. For millions of years, the Greenland ice sheet has acted as a colossal time capsule, preserving a catastrophic moment that reshaped the northern landscape in mere seconds. What if the planet we walk upon is merely a fragile skin, occasionally punctured by cosmic travelers traveling at speeds that defy our everyday understanding of reality? Scientists looking at radar maps of bedrock often find evidence of glaciers or volcanoes, but sometimes they find something else entirely: a near-perfect circular depression. In 2015, researchers analyzing NASA data noticed a strange, deep bowl hidden under the Hiawatha Glacier in northwest Greenland, prompting a decade-long scientific investigation. This 31-kilometer wide hole, large enough to contain the entire city of Washington, D.C., was clearly not created by the slow, grinding power of ice. The sheer geometry of the structure screamed of a high-energy event, something arriving from space with unimaginable force and carrying absurd amounts of kinetic energy. To create such a monumental crater, an iron asteroid roughly 2 kilometers across slammed into the Earth at approximately 17 kilometers per second, or 60,000 kilometers per hour. At that velocity, the kinetic energy released was comparable to millions of nuclear bombs detonating simultaneously, instantly vaporizing the bedrock upon impact. For years, the initial discovery was shrouded in mystery, with researchers debating whether this impact happened recently, perhaps even striking through an existing ice sheet. The relatively fresh morphology of the crater suggested a young event, possibly linking this cosmic collision to abrupt climate shifts experienced by early human ancestors. However, modern science relies on hard evidence, and radiometric dating techniques offered a very different and arguably more fascinating story about this buried secret. Using argon-argon and uranium-lead dating on grains of sand and melt rock, scientists discovered the impact occurred 58 million years ago in the Paleocene epoch. This revelation completely changes our understanding of the event. The asteroid did not strike a frozen wasteland, but rather a vibrant, temperate ecosystem. Greenland 58 million years ago was significantly warmer, covered in dense conifer forests, meandering rivers, and wetlands completely devoid of permanent glacial ice. When the asteroid arrived, it tore through the atmosphere, creating a blinding fireball before striking a lush landscape teeming with life rather than a desert of ice. The collision instantly melted the iron projectile and surrounding rock, creating intense temperatures that fractured quartz grains into microscopic, telltale planar deformation features. A transient cavity, far deeper than the final crater, opened up in seconds before the walls collapsed inward and the center rebounded upward in a massive elastic response. Molten rock pooled in the crater floor. Ejecta was blasted across the surrounding forested landscape, and a permanent scar was left on the Earth's crust. This was not a minor event, but a regional catastrophe that incinerated forests for hundreds of kilometers and injected massive amounts of dust into the atmosphere. The question that follows any monumental impact is simple, yet terrifying. Did this event drastically change the course of life on Earth? While the Hiawatha impactor was not large enough to cause a global mass extinction, it was certainly powerful enough to cause catastrophic regional destruction. Forests within hundreds of kilometers were instantaneously flattened or incinerated, while shockwaves triggered massive earthquakes that fractured the bedrock deep underground. Enormous amounts of dust and vaporized material were injected into the atmosphere, potentially leading to short-term cooling and several years of intense climatic perturbation. Despite these regional effects, scientists do not find evidence of a globally recognized extinction pulse clearly tied directly to the crater 58 million years ago. However, context is crucial. The Paleocene epoch was already a dynamic interval, with Earth existing in a warm greenhouse state before this event. Not long after the impact, the planet experienced the Paleocene-Eocene thermal maximum, one of the most dramatic rapid warming events in Earth's entire geological history. While there is no current evidence linking Hiawatha directly to this warming event, it reminds us how sensitive and evolving Earth's climatic systems truly are. The story of the crater continued long after the dust settled, transforming from a scene of destruction into a complex, hidden hydrothermal system. Researchers discovered unusual minerals like zeolite and microspherulitic melt grains, indicating that water interacted with hot melt material at extremely elevated temperatures. The crater likely filled with water relatively quickly via rivers, lakes, or groundwater infiltration, turning the scar into a temporary oasis for potential life. Impact heat can persist underground for thousands of years, and this circulating water would have altered rock glasses and possibly created unique habitable microclimates. These hydrothermal systems are increasingly recognized by scientists as potential temporary niches for life in the immediate aftermath of massive cosmic impacts. Over the next tens of millions of years, the slow process of erosion softened the dramatic morphology of the crater's rim and central uplift. Sediments accumulated and were later removed, but tectonics remained quiet, allowing the structure to survive without being destroyed by mountain-building forces. Then, only in the last few million years, the planet underwent a dramatic shift as global temperatures cooled during the late Cenozoic era. The Greenland ice sheet began to expand, eventually thickening into a massive, slow-moving river of ice that flowed across the landscape. This ice sheet acted as a protective, yet erasing, agent, burying the ancient crater under nearly a kilometer of compressed, flowing ice. The irony is poetic. A catastrophic event that vaporized rock is now hidden beneath a silent, frozen landscape that slowly grinds away at the surface. The scar was finally revealed not by human eyes searching the surface, but by advanced airborne radar surveys mapping the bedrock through the ice. The discovery of the Hiawatha crater completely reshaped scientific discussions about impact frequency, glacial modification, and the potential for life in extreme environments. For decades, researchers assumed that large impact craters beneath ice sheets were either non-existent or completely destroyed by the immense pressure of glaciers. Instead, Hiawatha demonstrates that a crater this size can remain hidden and largely intact under a kilometer of ice for nearly 60 million years. This discovery forces scientists to reconsider the completeness of Earth's geological record, suggesting many other cosmic scars lie concealed beneath active ice sheets. The crater is not just a relic of the past, it is a demonstration of how quickly the planet can erase and later reveal its most violent events. While the surface of Greenland today is an endless white expanse, the bedrock beneath holds a frozen memory of a day when the sky fell. This scar witnessed massive climatic shifts, surviving the transition from a temperate greenhouse world to the current brutally cold icehouse planet. The Hiawatha impact structure is one of the largest known impact craters on Earth, and it is the only confirmed one hidden beneath an active ice sheet. By studying this crater, researchers are gaining unprecedented insights into how impact melt materials and shocked minerals interact with glacial environments over deep time. The presence of shocked quartz in rivers draining the glacier confirms the crater's violent origin and serves as a natural forensic tool for further investigation. For years, the fresh appearance of the crater led some scientists to speculate it was incredibly young, perhaps linking it to the Younger Dryas cooling event. However, detailed radiometric dating anchored the impact firmly in the Paleocene, proving that morphology can sometimes deceive even the most experienced researchers. The crater's central uplift, a feature formed as the Earth's crust rebounded after the initial impact, still rises gently from the crater floor today. This subtle uplift is a silent testament to the unimaginable force that once fractured the billions of years old bedrock beneath the Greenland landscape. The story of Hiawatha reminds us that our planet is not a static rock, but a dynamic, evolving system constantly being modified by both internal and external forces. It challenges our perception of time, showing that events separated by millions of years can be linked by a single, perfectly preserved geological scar. The study of this crater involves an interdisciplinary approach, combining radar technology, geology, geochemistry, and even climate modeling to piece together its complex history. Researchers are now using the techniques perfected at Hiawatha to search for other hidden impacts in Antarctica and elsewhere, potentially changing our understanding of Earth's history. The Hiawatha crater is a testament to the power of curiosity and technology, forcing the planet to reveal secrets buried deep beneath its frozen surface. But behind the science and the data lies a simple, haunting image. A dense, quiet Arctic forest, suddenly illuminated by a blinding cosmic visitor. As we map the last remaining secrets of our planet, hidden wonders like the Hiawatha crater remind us how much is still waiting to be discovered. These buried stories don't just teach us about the Earth's chaotic history, they compel us to look at our own precarious existence with newfound humility. We live on a planet that is constantly evolving, transforming, and forgetting, yet it meticulously records its own violent encounters in the bedrock below. The Hiawatha structure serves as a humbling reminder of the sheer scale of cosmic forces that operate outside of human time and human history. The fact that a 31-kilometer scar can be swallowed by ice and overlooked for millions of years highlights the limitations of our perspective. It makes us wonder what other secrets, disasters, or even alien landscapes lie dormant beneath the white deserts of Antarctica or the deep blue of our oceans. The study of this crater is a testament to human curiosity, using satellites, radar, and isotopic dating to turn invisible secrets into tangible knowledge. While the Paleocene forests of Greenland are long gone, the knowledge we gain from their destruction helps us understand the resilience of Earth's ecosystems. By understanding the past, we are better prepared for the future, appreciating both the fragility and the enduring power of our world. The next time you look at a photograph of the endless, serene ice fields of Greenland, remember that beneath that quiet white expanse lies a forgotten, violent story. Earth is not just our home, it is a complex, active participant in a vast cosmic dance, capable of dramatic changes in the blink of a geological eye. The scar beneath the ice is a message from the past, a silent witness to a day when the green Arctic landscape was violently reshaped. As technology advances, we will undoubtedly find more of these hidden structures, each one adding another chapter to the epic story of our planet. The Hiawatha crater is just the beginning, a single puzzle piece in understanding the full, tumultuous history of the Earth's crust. We may never know if any life forms witnessed the blinding flash of the impact, but the rock remembers, holding the secret in its fractured quartz grains. The planet keeps its secrets well, but it never forgets, waiting for us to develop the tools to look closely enough to find them. The story of Hiawatha is a bridge between the deep geological past and our modern quest to understand our place in the universe. It teaches us that science is not just about answers, but about asking better, deeper questions about the world around us. So, as the ice continues to flow and the planet continues to turn, the hidden scar remains a quiet monument to a catastrophic day. Perhaps the greatest discovery of all is realizing that we are only just beginning to truly see our own world, one hidden scar at a time.